We are continuing the sum of subset problem. In this video, we will try to develop an algorithm for fixed size tuple solution using backtracking. Backtracking algorithms determine the problem solutions by systematically searching the solution space for the given problem instance. And what is solution space? All paths from the root to a leaf node define the solution space. And you can see there are 2 raised to n nodes in the solution space for the brute force approach. And can we reduce the number of nodes we have to visit or we have to generate using this backtracking approach? Let us see the algorithm. The sum of subset, it receives 3 arguments. Sum k and r. Sum is the sum of elements so far. Then k is the index and r is the sum of the remaining elements to be considered. Here initially it will be called as sum of subset s comma 1 comma r. K will be 1 and r is calculated here. R is the sum of all the elements. So in the initial call k will be 1 and r will be the sum of all the elements. Okay, let us check how this backtracking method reduces the number of nodes. For that, let us revisit the state space tree of a fixed size tuple formulation. See here, this is the beginning. Here you can see x1 equal to 1. That means you have considered the first element. One important thing is the array should be in sorted in ascending order. It is very important. The array should be in ascending order. Okay, so 7, 11, 13, 24. You have considered the first element 7. Then here you are going for the second element, that is 11, and then what is the sum here? It is 7. Then what is the sum here? It is 7 plus 11, 18. And here you are considering the third element, x3 equal to 1. You are considering this third element, it is 13. So the total sum 7 plus 11 plus 13, it is 31. 31, it is our target sum. So here we have met the target sum by considering first element, second element and third element. Okay, so here no need to consider the fourth element, because by considering the fourth element we never get a sum which is less than or equal to our target sum. So no need to generate nodes beyond this, or no need to descend through the tree beyond this x3 equal to 1. Okay, so we are not generating the remaining nodes. So in this way it reduces the nodes generated. Okay, and see here this without 7 in this set you can't generate a sum 31. So you will never get a result. You can't expect a result here. So your result will be in this area only, in this subtree, on left subtree only. Okay, so in backtracking we use a bounding function, and using that bounding function we will kill the node if it is not promising. That is x1, x2, x3 up to xk we have generated, and if it is promising or not, we have to decide that. So the sum up to considering the k elements, if we add k plus 1th element to that, if it is greater than our target sum, then we can say that sequence is not promising. We can kill that node, or we will never generate the nodes beyond that. Okay, in that way we can reduce the number of nodes. We can make the algorithm fast. Okay, let us see the algorithm for this. See, now know what is R, and initially the function is called sum of subset s comma 1 comma r. R is the sum of all elements total initially, and we can say R is the sum of the remaining elements to be considered in the running. Okay, let us move to the function, the sum of subset sum comma k comma r. Okay, then we are you can see x of k equal to 1, x in the result will be available the array x. See, if we consider the element with index I, then x of I will be 1. If we are not considering the element with index I, x of I will be 0. Okay, so we are blindly accepting x of k equal to 1, that is left subtree. We are accepting the element blindly, x of k is equal to 1. Then we will check sum so far plus the element k, wk. W is our set of elements. From there we have to construct the subsets. W is our set, so wk plus sum so far, is it equal to m? If it is equal to m, we will be printing the pattern. Then what will we do? We will go for generating the right subtree, that is excluding w of k. If we didn't make the sum, what will we do? We will check, is that leg promising? That is, promising means by adding the next element wk plus 1. We have accepted wk, we have made x of k equal to 1. That means we have accepted wk. Then is it promising? If it is less than m, by adding wk plus 1, the next element. It is, if that sum is less than m, our target sum, then that leg is promising. We will descend through the tree by calling sum of subset sum plus wk comma k plus 1 comma r minus wk. That is, we have taken kth element, so the sum of remaining elements will be r minus wk. Okay, if it is the first call, r will be the total sum of the total elements. Okay, all elements will be considered and their sum. We have taken the first element, then r should be reduced, so r minus wk. Then if we have met the sum, that is sum plus wk is equal to m, then what you have to do, we will try, can we create a sum by excluding wk and considering the next element wk plus 1. That is done here. Okay, so before that we have to check if we exclude wk, are there elements whose sum will be greater than or equal to m? That is sum plus r minus wk, is it greater than m? And we are excluding k and considering the k plus 1th element. Sum plus wk plus 1 is less than or equal to m. Then only we will exclude kth element and go for the, or try to construct a subset with k plus 1th element. So you can see by how to exclude kth element by putting xk equal to 0. Then we are descending through the tree with the k plus 1th element. This way this algorithm works. Then once the result is printed, you have to make xk is equal to 0 because you want to exclude that element by which you have got the result. So this is the algorithm. Then let us run this program. Let us see the data file. See, the numbers are in sorted order. First line is number of elements, second line the sum expected, then after that the data comes 7, 11, 13, 24. It is in ascending order. The program is decompiled. We are running that. We are passing this data file to that program. You can see 1110 and 1001. Do you remember what is 1110? You have considered the first three elements. What are the first three elements? 7, 11 and 13, which produces sum 31. You have excluded the last element with index 4. So you can see a 0 there. So 1110, that pattern. Then the next pattern is 1001. You have selected the first element. What was the first element? It is 7. Then second element 11 excluded, third element 13 excluded. Then you are considering the fourth element 24. So 7 plus 24 gives you a sum 31. So the number of nodes generated is 8, and you are getting this 8 by the variable count here. Okay, and this count is declared as the static integer count is equal to 0. Okay, next let us see which are these 8 nodes. That is the next thing we have to discuss. So let us trace the algorithm. See, initially it is called sum of subset 0, 1 comma 55. So here k equal to 1, sum comma k comma r. Initially r is the sum of all elements, so it is 55. K equal to 1. What it has to do? What it has to do? First it will make x of 1 equal to 1, x of 1 equal to 1. Then see the algorithm. It has to check sum comma wk is equal to m. Our sum is 0 now. Then it will fall in the if statement. Inside the if statement it will be trying sum plus wk plus wk plus 1. So sum is 0 and k is equal to 1, sum plus wk. This is our array w. So w1 is 7 and wk plus 1, 2 is 11. So 0 plus 11 plus 7 plus 11. Is it less than m? Yes, it is less than m. So it will call sum of subset sum, that is s sum plus wk. Sum so far is 0, sum plus wk, that is k is equal to 1, so 7. So 0 plus 7, 7. Then k plus 1, k will be incremented. Then we have accepted 7. So we have to reduce the remaining sum. So previously it was 55, 55 minus 7. So it is 48. Okay, and this call will generate a next node. So there sum is equal to 7 and k equal to 2 and the remaining sum is 48. Then it will do x2 equal to 1, x2 equal to 1, here k equal to 2. Then it has to check whether it has raised the target sum, that is sum plus w2. w2 is 11. No, it is less than m. Then it has to do the else part, that is sum plus wk plus wk plus 1. Sum plus the sum is 7, sum plus wk, w2 is 11 plus wk plus 1. It is less than or equal to m. Yes, it is less than or equal to m. You are getting a 31, less than or equal to m. So it is invoking sum of subset sum s plus wk, s plus wk comma k plus 1 or minus wk. Okay, so it is sum is 7, k is 2. Sum plus wk is 7 plus 11, 18. Then k plus 1, it is 3. And sum remaining was 47 and we have considered 11. So it has to subtract 11 from 48. So you are getting 37. Okay, so no node is generated. Then what it has to do? What this node has to do? First it has to make x3 equal to 1. That is blindly accepting. Then it has to check sum plus wk, that is sum is 18 and k is 3. What is w3? w3 is 13. So 18 plus 13 equal to 31. So equal to m. That is correct. Then what it has to do? It has to print the array x. Okay, it has to print the array x. Then after that, it has to create the right subtree. So before creating the right subtree, it has to do the check whether sum plus the remaining sum is greater than or equal to m and sum plus wk plus 1 less than m. Okay, it has to do that. So it is doing here. Sum plus the remaining sum is 37 plus wk, k equal to 3. So 37 minus 13. So 24. So it is greater than or equal to m. Okay, it is correct. And next condition, that is sum plus wk plus 1. K is 3, k plus 1 is 4. So w4 is 24. w4 is 24. So 18 plus 24. Is it less than or equal to m? Our m is 31. Never. So that condition is wrong. So it will never create the right subtree. Okay, it will never create the right subtree. So it will make x3 equal to 0 and it will return. Okay, it will return. So this function is returning. This instance is returning. Then it has done this call. Then what is remaining? The creation of right child. So before that, it has to do these two checking. If they are succeeded, then only it will be creating the right subtree. Okay, then what it has to check? Sum minus, here sum is 7. Sorry, sum plus remaining sum minus wk. Okay, wk is k is 2 here, so second element is 11. So sum plus remaining sum is 48 minus 11. Is it greater than m? Okay, it is greater than m. And then sum plus wk plus 1. K is 2, k plus 1 is 3. So our third element is 13. So it is 7 plus 13. Sum plus wk plus 1, sum plus 13. It is less than m. Okay. Then it is generating the right subtree. Okay, now it is generating the right subtree. Okay. Then that condition is succeeded. Then what is the thing it has to do very next? This condition is succeeded. It has to make xk equal to 0 and do sum of subset. Okay, so it is making x2 is equal to 0, then making sum of subset. Sum is 7, k plus 1 and r minus wk. R minus wk. So what is r? R is 48. 48 minus k is 3. W3 is 13. So it is 37. 48. Sorry. K is 2. K is 2. So what is second element? It is 11. So 48 minus 11, it is 37. Okay, then what this function has to do? First it has to make s of k is equal to 1, x of k is equal to 1 and check whether sum plus wk, that is case 3 7 plus w3 is 13. Is it equal to m? No, it is not equal to m. So it is coming to the else part. In the else part, it has to check sum plus wk plus 1. Sum is 7, k is 3, third element is 13 plus the next element 24. Is it less than m? No. So it is going to generate the right child. Before that, it has to make the checks sum plus r minus wk. Sum plus r minus wk. Is it greater than m? Yes, it is greater than m, and it has to check sum plus wk plus 1, the next element. Is it less than m? Or equal, less than or equal to m? Yes, it is less than or equal to m. So it has to generate the right child. So it is generating this link. It is generating this one. Okay, with sum equal to 7, k equal to 4, and remaining sums equal to 24. Okay, then it has to check s plus wk is equal to m. K is 4, wk is 24. So 7 plus 24, it is our target sum 31. So it is printing x. Okay, it will print x. Then it will check after printing. It has to check the conditions for creating the right child. Okay, the conditions for right child, it is sum plus r minus wk. W of k, is it greater than m? This will be false. Sum is 7 plus what remaining sum 20, remaining sum is 24 minus wk, that is 24 again. So it will not be greater than m. So this is blocked. So beyond this, it is won't descend. Okay, now it is time to return. It is returning. So after printing, it has to make x4 equal to 0. So it is returning. Here it has nothing to do. So it is again returning. Here it has done all the activities. So this also returns. Okay, this also returns. Here what is remaining? The conditions for creation of right leg is remaining. So it will check the conditions, and both conditions are satisfied. It will generate the right subtree. Here again it will check the conditions. So left child is created, then the conditions becomes false, so it will not go further. It is trying to generate the right child. Okay, the right child is created here. The right child is created here. With sum is equal to 0, k equal to 3 and 37, the remaining sum. So it's making x3 equal to 1, that is, it is accepted. But the condition sum plus wk plus wk plus 1 is less than or equal to m, it becomes false. Then sum plus r minus r is 37, r minus wk is greater than m. No, it also becomes false. So it is not proceeding to create the left child, and it is not proceeding to create the right child, and it is returning now. Okay, now it is returned. From here it is returning. So here nothing to do, again it is returning, and here now completed all the activities, so it is returning. So how many nodes it has created? 1 2 3 4 5 6 7 and 8. So this is the number of nodes generated, 8, in our program. Okay, here the bounding function we are using is, if we have a sum after excluding wk is available, and sums of r plus the next element, that is wk plus 1, is less than or equal to m, then only we will proceed to generate the node. So in this way we can reduce, by using this bounding function we are reducing the number of nodes in the solution space. Thank you.